Okay, well, welcome to chapter 1.3, Modeling with Linear Functions. The essential question for this chapter section is, how can you use a linear function to model and analyze a real-life situation? What you will learn in this chapter is to write equations of linear functions using points and slopes and finding lines of fit and lines of best fit, be it with or without a calculator. Okay, core concept, writing an equation of a line. Given the slope m and y-intercept b, if you know the slope and you know the y-intercept, you use the slope-intercept form y equals mx plus b. But if you're given the slope and just a point that is on that line, then you have to use the point slope formula. And that is y minus y sub 1, which is the y value of that point they gave you, equals the slope times x minus x sub 1, which is the x value of the point they gave you. And then given up 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, you first have to use the slope formula to find m, and then use the point slope formula using either of those 2 points, be it x1, x1, y1, or x2, y2. So you find the slope, and then you use the point slope formula up above. Okay, so let's delve in. Okay, example 1. Get my highlighter out. Writing a linear equation from a graph. The graph, right here, shows the distance asteroid 2012 DA14, that's the name of the asteroid, travels in x seconds. That is how far it travels in x seconds. Distance in miles is y, time in seconds is x. Miles per second. Write an equation of the line and intercept the slope. Okay. I think there's a misprint there, but anyhow, they want us to write a slope-intercept equation of the line. The asteroid came within 17,200 miles of Earth in February of 2013. About how long does it take the asteroid to travel that distance? Okay, so the first thing I want to do is write the formula for what's the equation of a line? Y equals mx plus b. Okay, my b is my y-intercept. My y-intercept is 0. So this is 0. My slope is rise over run, if you will. Here, let me erase that. My slope is rise over run. So I went from 0, and what I want to do is find a corner that it's on, and they gave us the point 524. So it went up 24 over 5. So that is my slope, rise 24 over 5, x. Okay? Y equals 24/5 x plus 0. Okay? And if I want that as a decimal, we could also do that. So 5 goes into 24. Let's write it like that. Y equals 5 goes into 24 4 times with a remainder of 4. 5 goes into 48 times. That's 8.8. 4.8x. And plus 0 just goes away. So this is the equation of the asteroid's graph. So what does this mean? In 5 seconds, it went 24 miles. It's going 4.8 miles per second. That's what that means. So our slope in this case, our rate of change is miles per second. And it's 4.8 miles per second. Okay, so now continuing on, it says the asteroid came within 17,200 miles of Earth. About how long does it take the asteroid to travel that distance? Okay, so this is distance, miles, that's y. So I'm going to substitute that in for y. So I'm going to use my equation y equals 4.8x, and this is my y. 17200 equals 4.8x. Divide both sides by 4.8 to find out how many seconds. Hey Siri, what's 17,200 divided by 4.8?
17,200 divided by 4.8 is approximately 3,583.3333.
Okay, so 3,583 and 1/3 miles per second. Actually, it says about how long does it take the asteroid to travel that distance. So it's not miles per second, it's seconds. 3,583 seconds. Okay, and since it's in seconds, we will leave it at that. But we could go on and say, hey Siri, what's 3,583 divided by 60?
3,583 divided by 60 is approximately 59.7166
minutes. I divided by 60, so there are 60 seconds in a minute, and so therefore they're saying 59.7166 minutes, or 1 hour, basically, just a few seconds away from an hour. So it's going 3,583 miles per hour, or per minute. No, per minute. 59 miles per minute. Okay. That's not right. 59.7 minutes to go that distance. Let's leave it at that. Okay. So because the asteroid are 3,600 seconds in 1 hour, it takes the asteroid 1 hour to travel 7. Yeah, it is 1 hour. About 1 hour, 59 minutes to 1 hour. Okay. I didn't misspeak, but anyway, let's move on. Okay, example 2, we're going to the prom. Modeling with mathematics. 2 prom venues charge a rental fee. Okay, so proms are held at venues. Venues charge a rental fee. The table shows the total cost for different numbers of students at Lakeside Inn. So Lakeside Inn, didn't I switch to that? Okay, Lakeside Inn is the table. The total cost Y in dollars for X students at Sunview Resorts, represented by this equation, Y equals 10X plus 600. Okay, so it says which venue charges less per student and how many students must attend for the total cost to be the same. Okay, so we already have one equation, Y equals 10X plus 600. Okay, and that's going to be Sunview Resorts, and then Lakeside Inn is going to be another equation. Okay, so first thing we want to do is look at this table. And in order for this to be linear, your X has to change the same rate as the Y. So this is going up 25, up 25, add 25, add 25. 1,500 to 1,800 is 300. Add 300, add 300, add 300. This is linear. And in order for us to find the equation of a line given points, we have to take 2 points and find the slope first. Okay, so it doesn't matter what 2 points we use. Let me use blue here. Blue. Pen, blue. All right, let me look here. It doesn't matter which one we use. We could use, let's make it easy. Let's use these two. Pick any 2 points and you say M equals Y2 minus Y1 divided by X2 minus X1. There's my formula for slope. Then you say M equals Y2, 2,700, minus Y1, 1,500, divided by X2, 200, minus X1, 100. Okay, simplify. 2,700 minus 1,500 is 1,200. And that's divided by the difference between 200 and 100 is 100. So M, our slope, our rate of change, if these two zeros cancel, that would be 12. 1,200 divided by 100 is 12. So the slope is 12. And then we write y minus y1 equals m times x minus x1. Okay. And you can pick any point you want. So I will choose the smaller one here, 1,500, 100. And this is our y1. And we just write y minus y1, which is 1,500, equals our slope, which is 12, times x minus the x value from that same point, 100. In simplifying this, we get y minus 1,500 equals, and when I distribute this, I get 12x minus 12 times 100 is 1,200. Add 1,200 to both sides to get x. Oh, hang on. Let's not do that. We're trying to find the equation. So I'm going to add 1,500 away from y. And when I do that, I get y equals 12x plus 300. Okay, so there's my other equation. That is the equation of the table. Okay, so you need to understand what linear equations are for. All right, the x is the number of people who are going to the prom. How many people? If one person goes to the prom, 10 times 1 is 10, plus 600 would be $610 is what the resort would cost. Lakeside Inn is going to charge, this is the number of people. So if one person goes, it'd be $12 plus 300 or $312. Make sense? So you plug 2 in, you find out how much it would cost if 2 people show, or 100 people, or 300 people, and that's what you use. So the number in front is the cost per person plus a flat rate. That they're charging $600 plus $10 per person, and Lakeside Inn is charging $300 flat rate plus $12 per person. So what this question is asking is which venue charge less per student. Okay, so then we're going to focus on the cost per student, which is right here. And $10 per student is the Sunview Resort, and Lakeside Inn charged $12 per student. So the answer to that is Sunview Resort charged $2 per person less. Now it says how many students must attend for the total cost to be the same. I'm going to highlight that right there. Cost to be the same. Well, when the total costs are the same, these are linear equations, and the solution when they're the same is when the lines intersect or cross. When does that happen? When they're equal. So I have y equals 10x plus 600. I have y equals 12x plus 300. I set them equal to each other, and I find out at what amount would it be equal. So I take 10x plus 600. Let's change colors. Let me click on that and change it to purple and go back to my purple pen. So 10x plus 600, which is right here, equals 12x plus 300. Okay, move the smaller x first. 10 is less than 12, subtract 10x so you don't get a negative number of variables. So 600 equals 2x plus 300. Subtract 300 from both sides, and I get 2x equals 300. Divide by 2, divide by 2, x equals 150 people. Okay, how many students must attend for the total costs to be the same? 150 students must attend each venue for the price to be equal. Okay. Okay, so I decided to do this in Desmos to show you the graphs. So y equals 10x plus 600 was which one? 10x plus 600 was Sunview Resort. Lakeside Inn was 12x plus 300, blue. So these are the two resorts. They intersect right here, and it was at 150 students. It would cost $2,100 to rent that venue at both. So what's happening here? This value here is the constant, or the initial cost, the flat rate, $300 on this one. And this one up here is $600. Okay, so let me go back. There's our y-intercept, 600 and 300. And then obviously our rate of change, or our slopes are different. The blue line, 12, is greater than 10. They're charging $12 per student, so it's gradually catching up by $2 as you add people. And they meet at, as I said, 150, 2,100. 150 students would cost $2,100 to rent that venue. Okay, core concept, finding a line of fit. All right, there's a new definition, new word, line of fit. Okay, it's very statistically driven or related to statistics. Step one, create a scatter plot of the data. So if you're given a bunch of data, you want to do a scatter plot. Then you sketch a line that most closely appears to follow the trend given by some data points. There should be about as many points above the line as below it. Choose 2 points on the line and estimate the coordinates of each point. These points do not have to be the original data points. Then step 4, write an equation of the line that passes through the 2 points from step 3. This equation is a model for the data. So that's what we'll be doing here. Okay, example 3, finding a line of fit. The table shows the femur lengths in centimeters and heights in centimeters. So that's our x and our y. Femur length x, height y. Of several people. Do the data show a linear relationship? If so, write an equation of a line of fit and use it to estimate the height of a person whose femur is 35 centimeters long. So the first thing we're going to do, if I go back to our steps here, is step 1, create a scatter plot. So I've done that. I've gone into Desmos and I plotted it. But I want to show you a feature that Desmos has. So this was really, when I first did it, 0, 0 was here and we were zoomed way in and I couldn't see them. But obviously you can find X's and Y's being large. So you just scroll out and, oh, there they are. But I can adjust my window. I could go from -50 to 100 on the X, and I could go from -50 to, so I could, what I'm saying is I can change my window. So if I go in and I change my axis, so let's make this -50 on the X axis. Okay, so that brings us over to -50, but I want to stop it at 100. None of my values go above 50 actually. So I could stop it even shorter, let's say 60. So X goes from -50 to 60. Okay. All right, so what just happened? Oh, there it is. All right, and now I can see it a lot better. So there's my scatter plot going from 0 to 60 and 0 to 200. I've zoomed in, and that's a nice window right there. And it appears to be linear. So now if I go back to my question, do the data show a linear relationship? So you look at the picture and you say, yeah, that looks like it's pretty much on a straight line. It's increasing from left to right and they look like they're about on the line. Okay, and then we're going to draw a line through that eventually. So it says, if so, write an equation of a line of fit and use it to estimate the height of a person whose femur is 35 centimeters long. So we're going to come up with a linear equation and we're going to use 2 points. Now the book chose these 2 points and I'm going to use them because it's a good choice. Because if you subtract, remember what the slope equation is. Let's write it. So I want to find the slope first. M equals y2 minus y1 divided by x2 minus x1. So if I'm looking at my x's and my y's, my x is my denominator. And if I subtract two of them, 50 minus 40 is 10. When you divide something by 10, it just moves the decimal place. It makes it nice and easy. So I'm going to choose those 2 points. So I'm going to take y2, which is 195, minus y1, which is 170, and divide that by 50 minus 40. And that is going to give me 25 over 10. Well, that reduces to 2.5. Okay, so there's my slope. So now I know what m is. M equals 2.5. And if I use one of these 2 points, I'll use this one, I can find the equation of the line. So I write y minus y1 equals m times x minus x sub 1. That is the point slope formula. I have a point, I have a point, I have a slope. That's why it's called point slope formula. So I'm going to write y minus, I'm going to substitute my givens. Y1 is right here, and that is 170, equals m, which is 2.5, times x minus x1, which is 40. Simplify by distribution. Don't do anything on the left yet. Distribute this side. 2.5 times x is 2.5x plus 2.5, not plus, minus. Watch your signs. Minus, well, 4 times 2.5 is 100. 40 times 2.5 is 100. Adds 170 to both sides, and we get our linear equation. Y equals 2.5x plus 70. Okay, so I'm going to check that. I'm going to go to Desmos and put that in. Y equals 2.5x plus 70. So I'm going to go here, enter, y equals 2.5x plus 70. And there's my line of best fit going through there. And the 2 points I chose to determine the slope of that are on that line, and the others, some are above, some are below, and that's a nice fit. You want about the same above and the same number below. Okay, so that is how you do a line of fit. Now we've come up with a line of best fit, we use it to approximate. Now, since we have a line of best fit, then you expect there to be a trend. So if this is the trend, then you can do an estimate. So now what the question is asking is, estimate the height of a person whose femur is 35 centimeters long. So if we go here, the 35 is right here. And so therefore we would go to this line here and go over here. And I would say that that person would be a little more than 150 centimeters tall, 160, 70, 80. I'd say closer to 160. So let's check it with our equation. So 35 centimeters long, that's the femur length, that's our x. So to use our linear equation to do our approximation, y equals 35 is my x. So I'm going to do 2.5 times 35, that's coming from here, plus 70. Y equals 35 times 20. I'm just going to save time here. Hey Siri, what's 35 times 2.5? Hey Siri, what's 35 times 2.5?
35 times 2.5 is 87.5.
Plus 70. So y equals 0.5. 7 plus 0 is 7. 8 plus 7 is 15. So the person with a femur length of 35 centimeters, we are estimating their height to be 157.5 centimeters tall. And as I said in here, I said it would be closer to 160, and that's pretty accurate. Okay, so that's how lines of fit work. Okay, so I brought my handy dandy TI-84 Plus Silver Edition Texas Instruments graphing calculator emulator to my screen. Because example 4 says using a graphing calculator, use the linear regression feature on a graphing calculator to find an equation of the line of best fit for the data in example 3. Estimate the height of a person whose femur is 35 centimeters long. Compare this height to your estimate in example 3. So let me go get that table. Okay, so here's the table. So I have my graphing calculator on, and I always clear my home screen. I go to y equals. I want to turn the plot on. So I go arrow up and press enter and then arrow back down. And now it says plot is on. I want to go to stat and I want to edit. So I press enter and it's asking me to enter this data. So X is going to be in the column L1 and Y is going to be in column L2. So I'm just going to enter these. So it's 40, the 0 failed, 40, 45, 32, 50, 37, 41, 30, 34, 47. Oops, I always hit backspace and I can't do that. Backspace is here. 47, 45. So 50, 37, 41, 30, 37, 45, enter. So now when I'm on that last one, right here, there is a parentheses and it says 10. That tells me how many entries I have done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just verifying I substituted everything into the calculator from this table. Then to get to L2, I press the right button to get over here. And now I'm going to plug in these Y values. So 170, arrow down on my computer, 183, enter, 151, enter, 195, enter, 162, enter, 174, and so on. Okay, when you're done, you better have the same number in L1 as you do L2, because if you don't, and there's one, you're off by 1 or 2, it's going to say error mismatch. X's have to match the number of Y's there are, or this thing will not work. So I've entered this data into the calculator, and now I'm going to hit, let's see, what do I do next? So I'm going to hit stat, arrow over to calculate. I want a linear regression, that's 4. So I'm going to arrow down to 4, or I could have just pressed 4. And X is coming from L1, Y is coming from L2, and I'm just going to leave all of these blank, and I'm going to hit enter, and it will calculate it. So there is my equation. So I'm going to write that down. It told me that A, so Y equals MX plus B is a linear equation. The graphing calculator puts an A where the M is. It means the same thing. Y equals AX plus B. A is our slope, and then it tells us A is 6.06. So that would give me an equation Y equals 6.06X plus, and my Y-intercept is negative 87.67. So it's minus. So it's going to be minus 87.67. Okay, so there's my linear equation that the calculator came up with. Okay, and when I hit graph, all it shows is negative 10 to 10 on my graphing calculator. Well, these numbers are bigger. So if I hit zoom, which is right here, and I go down to statistics, zoom stat. I know this seems like a lot, but once you do a few of these, it comes to you and you just do it. Zoom stat. So there is my scatter plot of these points, but I see I've got a point down here and I don't want that. That's, I think, an error. So I'm going to go back to my table, stat edit, and there it is. I have a 1 for 30. And it should be 141. 151, 185, 182. Okay, so this is going to be incorrect. I made a mistake, and so let me get rid of this. Notice what I just did though. I graphed it, zoom stat, zoom stat, clear, zoom stat. Why is it doing this? Zoom stat. Huh, it's not graphing now. Graph. I gotta hit the word graph button, I guess. That's why. All right, so that point that was at 30 comma 1, which is way down here, it just moved it up to there. So I noticed there was a number way off. So now they're all in line. So that's much better. Okay, now I'm going to find the linear. Whoops, let me plug this in a minute. Now I got to find the linear regression again. So let's go through that again. Stat, arrow over to calculate, 4, enter, 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 enter. And now it is y equals 2.6 x minus or plus 64. Actually, it'd be 65. 64.99 is pretty darn close to 65. So 2.6 x plus 65 is my linear equation. Okay, so the graphing calculator does not have a cut paste feature, but it does. We just have to figure out how to do it. So in order to do that, we press vars. I want to go down to statistics, which is 5. I want to arrow over to EQ, regression equation, and press enter. Okay, and that did that on the home screen. And like I said, it's been a while since I've done this. Let's do it again. You want to hit y equals, you want to graph it, y equals, and now we do vars 5, EQ, enter, enter, graph, and there's our line of fit. So that is now our line of regression. And now I can approximate. I can approximate at 35. So if I use that graph now and I go to the calculator, I can use that data, the equation, and notice it didn't round it. It shows it all. So if I arrow to the right here, y equals 2.60357, blah, blah, blah. There's my x plus 64.99. So it's just showing a whole bunch of decimal values there. So it is the linear equation, though, that I have written here, but this is rounded. Okay, so now I hit graph. And now I can go second ask, second calculate, or actually it's just trace. And I want to know where 35 is. So tracing. All right, let me see. Okay, so now I want to calculate a value. I want to know when x is 35, the femur length, what is the height of the person going to be? So I can go second calculate, see where it says calc there for trace, and I want to plug in a value. So I just hit enter, and I want to plug in 35, and I hit enter, and it gives me the value y being 156. So I'm going to write that. So when x is 35, so it'd be like, if we did it manually, this would be 2.6 blah blah blah, whatever that rounded was, times 35 plus 65 is going to give me this y value here, which is 156.12 centimeters. That is the height of the person with a femur of length 35. So we got 156.12 centimeters. Now it says to compare the height of your estimate in example 3. Well, what did we get in example 3? 157.5. So it's off by 157.5. It's off by 1.4 centimeters. So it's still pretty close. The calculator is more accurate than this process. Just picking two random points is not as accurate as doing an actual regression in your calculator. Okay, that brings us to the end of chapter 1.3. And now it's time to go do your exercises. So do numbers 3 through 24 if you're in my class, and have a great day. See ya.